In this example, we are given the following polar equation, and we are asked to convert it into a rectangular equation and then graph what we are given, or what we come up with, I should say. So, given that r is equal to 6 cosine of theta, we have to remember all the formulae for translating from polar to rectangular and vice versa. So, they are that x is equal to r cosine of theta, that y is equal to r sine of theta, that r is equal to the square root of x squared plus y squared, and that theta is equal to tan inverse or arctan of y over x. All right, now we can get to work. Well, I see that I don't have an r times a cosine. I've just got r by itself here, and likewise I just have cosine by itself. So I'm going to have to get a wee bit creative, and what I can do is I can recognize that, well, if x equals r cosine, doesn't that imply that x over r equals cosine? Why, yes, it does. So here's what I'm going to do. I'm going to hold off on substituting in the r. I'm only going to substitute the fact that cosine of theta is equal to x over r. Bear with me, it will make sense. So then r is equal to 6 times x over r. Well, this is cool because now I can multiply both sides by r, and that gives me r squared is equal to 6x. Well, what is r squared? Well, if r is the square root of x squared plus y squared, then r squared is just x squared plus y squared. So I have that x squared plus y squared is equal to 6x. Now, technically speaking, this is in rectangular form, but it's a good idea to simplify it into a form that is familiar to you. So a circle, an ellipse, a hyperbola, a parabola, or I don't know, something else we weren't expecting. We want to look at it and tell what we have. Now, as is, I can't do that. And besides, it asked us to graph it as well, so we kind of need to do that in this case. So what I'll do is I'll subtract the 6x from both sides. Why will I do that? Well, I see that I have an x squared here, and I also have a y squared. And so equals 0 doesn't really tell me anything, but maybe I can manipulate this a bit. And if I complete the square on this term right here, the x squared minus 6x, I will basically have the equation of a circle where it's centered at a y coordinate of 0. You can think of this as y minus 0 squared. So let's do it. Remember, the way you complete the square is you take the middle term, which in this case is negative 6. You divide it by 2, and you square it. So this here would be negative 3 quantity squared, which is equal to 9. Well, if I add this to both sides, I have plus 9 here, plus 9 here. And factoring this now, I get that x minus 3 all squared plus y squared is equal to 9. Remember that when you complete the square and you go to factoring this, you can do it the old school way, or you can just remember that the b over 2 term will always be what goes right here. No pun intended, b. So if I look at this, well, this is my equation of a circle. So now I can graph this pretty easily. Well, it's centered at x equals 3, so 1, 2, 3, and y equals 0, so it's centered right here. And then this is equal to 9. Remember, the equation of a circle is x minus h squared plus y minus k squared equals squared, not just r. So my radius isn't 9, it's 3, because 3 squared is 9. So I'll mark this, and I know the circle goes 3 in each direction, and over here as well, so that would be about here, and there we go. Now, of course, I'm assuming that theta is just allowed to go from 0 to 2 pi or go anywhere. If the problem does not tell you what a variable ranges over, in this case theta, you just assume that it ranges over everything that it can do without causing undefined issues like division by 0. So there we go. Given our equation, r equals 6 cosine theta, that can be rewritten in the rectangular form x minus 3 squared plus y squared equals 9, which is the equation of this circle, if you can call it that with my terrible art skills. And that is this example.